So a few years ago, I moved from teaching 6th grade to teaching 8th grade, and my colleague, Mr. Fitzgibbons, moved from teaching 7th grade to teaching 8th grade. And on our way moving up, we were discussing with the high school teachers, what's the biggest issue that kids have at the high school? And they said subtracting integers. Now, fast forward another year, and we were talking to the 7th grade teachers. We said to them, what was the issue that students had the most trouble with? They said subtracting integers. And at first, it's kind of like, well, how hard can it be? These are cute, cuddly, single-digit numbers, and even double-digit numbers if you look at this example down here. I guess what we discovered through experimentation of seeing students do this again and again is that these cute, fuzzy numbers, the problem with them is that students develop a false sense of confidence when they do the problems. You think you're having a day at the beach because it's single-digit numbers, but in reality, these single-digit numbers have teeth, and these teeth can bite. Let me show you what I mean. Take this problem right here, -3 minus 7. Your quick brain, your fast-thinking brain, sees the numbers 3, sees the number 7, and sees the subtraction sign. So automatically, what goes on is either this or this. 4 or -4, and you probably are saying, well, the 3's first, and you're taking 7, so the answer's got to be -4. And then we'd say to you, well, no, it's not -4. The answer is actually -10, and I'll run through the reasons for why the answer should be -10 here. And the student will just smile at us and say, oh, yeah, it is -10. They don't feel the pain of getting it wrong until they have to take a quiz. It's kind of like if you put your hand on a stove when you were little, you'd feel the pain immediately. Well, imagine putting your hand on the stove and not really realizing that it's hurting you, and then someone gently reminds you to get your hand off the stove because it's hurting you.
You should not put your hand on that stove, young man. It's very hot.
Oh yeah. Thanks. This situation might seem unrealistic or even a little silly, but it's actually what students are doing when they make mistakes subtracting integers. They're failing to feel the pain of their errors, so they don't change their methods. And they get burnt all year as 7th graders, then as 8th graders, and all the way into high school. Well, what we want to try to do instead, and you can do this at home or in school, when you get something wrong on this furry, friendly, single-digit number problem, if you get -4 or +4 when the answer should be -10, get used to screaming in agony. Ow! You want to know that it hurts. My advice to you, before you say that you've mastered this topic, is to get 7 in a row correct. So let's look at this one right here. We have 6, and we're taking away -2. If we were to look at that one, again, my quick brain would say, okay, 6 minus 2, that equals 4. But we're not taking 2. We're taking -2. That's why this number is in parentheses. There's a negative there. You can see here the reality is if I have 6 to start off with, 6 is, as we've learned in a previous video on adding integers, is the same as 6 of these yellow circles. And then -2, we have to take -2. Remember, negatives are the red circles. I don't have any red circles to take here. So in order to develop red circles, I am actually going to bring in a yellow circle with a red circle, because if you remember, this is called a 0 pair. And so in reality, I still have 1, 2, 3, 4, 5, 6, because this right here, even though there's a 7th yellow dot, it combines with a red dot to equal 0, so you still have 6 yellow dots. So I'm going to do that one more time because it says to take -2. So now you can see I have 6 positives, and this is 0 and this is 0. The problem asks me to start with 6 positives, which I have, and now I'm going to take -2. So if I'm taking -2, that means I take this, that's taking -1, and I take this, that's taking -2. What are you left with? You're left with 8. And think about it another way. If I am taking away a negative, it's like in the real world, if you owe me $2 and then I say to you, oh, you don't have to pay me that $2 back anymore. You just gained $2 in essence. So you might have started with $6, now you have $8. Seeing in a more familiar way, this is the first grader in you. 5 take away 2. You've seen this problem before. But I want to show you it just to show you why all the trickier ones, the ones where you're taking away a negative or you're starting with a negative, why those work. So I start with 5 positives, you see that here, and I need to take 2 positives. Notice there's no negative sign here. We interpret this sign right here as take away. So I'm going to take away 1, I'm going to take away another, and therefore I'm left with 3. Easy enough. Let's take a look at another one. This is a little bit more tricky because you're less familiar. You wouldn't have studied this in first grade. We start with 5 again. And we're taking away 2 negatives. You notice I have no negatives here. So again, what do you have to do? Hopefully you said add a 0 pair. So I'm adding 0. The negative and the positive equals 0. I need to add another 0. Because there's ultimately going to be 2 negatives taken. And now I still have positive 5, and I can take 2 negatives. So let's get rid of this negative, and let's get rid of this negative, and you're left with 7 positives. So 5 minus negative 2 is positive 7. Start with negative 5. And again, we need to take 2 positives, but there are not 2 positives here, so we've got to create those positives. So I'll do a 0 pair. So I've just added nothing to the group, and I'm going to add nothing to the group again. And now I can take 2 positives. So let's get rid of this. Let's get rid of this. And what are you left with? 1, 2, 3, 4, 5, 6, 7 negatives. So the answer to negative 5 minus 2 is negative 7. And if you don't believe that, if that doesn't make sense, again, think of it in terms of money. You start by owing somebody $5. Let's say you owe me $5. And then you take $2 from me. That means you owe me $7. You better pay me back. Negative 5 minus negative 2. So this is pretty simple. I think you're getting the hang of this. We don't need these counters anymore. Negative 5 minus 2 is just going to be negative 7, right? It's the same thing as the last one, right? Aren't these, they're pretty much the same thing. So you should get negative 7. Ow! I'm just kidding. I'm just kidding. Hey, listen, you got to be careful of that. So let's actually do it out, and I'll show you why this is actually wrong. So I started with negative 5. And now I'm asked to take away 2 negatives. Do I have 2 negatives to take away? I do. So we can take this away, and we can take this away, and we're left with negative 3. Now, I love manipulatives, these little chips here. In real life, if we were playing with them in 3D, we'd call them manipulatives. And we use counters a lot of times to show this lesson in school. And some people say those are for little kids. I think it's a great way to understand, and modeling is something that people use all the time in the real world at the highest levels of mathematics. Think of architecture. But I do want you to eventually just be able to manipulate these numbers pretty quickly in your head.